Welcome, Bartosz. Dr. Sawik is a researcher in the management faculty up to now. Yeah, he is doing research in the optimization, risk analysis, and we are very interested, especially in this part, which is related to the risk analysis, because this analysis is obligatory for the space missions. We did a lot of risk analysis up to now for our missions. That we will start next mission tomorrow. We will launch our satellite tomorrow afternoon. That we are almost ready to do. Please, the floor is yours.
Thank you for the invitation. When I was invited by Professor Wu to this talk, first we agreed that I should have like 3 slides. Then after tough negotiation, we agreed to 10 slides. So I was slightly extend the amount of slides, but I hope it's not going to be very demanding amount of information. So the title of my talk is Why Multi-Criteria Optimization for Space Mission Planning is Helpful. Well, we can answer very simple, why not? But I hope I will be able to show you some reasons for using the multi-criteria with connection to the metaverse, the digital twin, to build a reasonable and, let's say, promising decision supporting system for space mission planning, space mission preparation. Okay, so at the beginning, I have to say something about myself. So you have seen that I have 3 affiliations, one at AGH University. I have been a visiting professor several times at the Public University of Navarre in Pamplona, and also a visiting scholar at Berkeley. Also, I finished an executive course at Berkeley. But to say anything about myself, first of all, I think the most important information on the slide is the picture of Zakopane during the winter, so nowadays, because I'm from Zakopane, so I would like to present myself. So about my activity, I have some, as I said, some activity in Poland, some activity abroad. I think the most important is probably this abroad, so visiting stays abroad in Spain, in US, in United Kingdom, Portugal, Austria. I also have been already 3 times PhD thesis reviewer in Spain. Also, I have some majority of research grants in Spain. 2 are at the moment in a continuation process. We are also applying for 1 grant now. I'm going to explain what is the purpose, because this grant is going to be related with the space technology. And about Poland, well, I was trying to do my best as a faculty at AGH University to sign some Erasmus agreements, to survive with the academia salaries. I also have been an innovation project evaluator and research and National Center of Research and Development and Bridge Alpha, also in PARP, some other things. So I was, main reason is to have some, background, what is going on with the innovation in relation between business and the industry. Okay, so more or less, this is the introduction. And the next slide is also introduction. And I think the most important are these pictures in the top, because that is going to be some explanation about my research path, what I have been involved. So I start with the multi-criteria optimization. So the first picture on the upper right corner. Then I decided that maybe the multi-criteria would be interesting to apply with the portfolio problems. So the second one is the portfolio, and my PhD was about the multi-criteria portfolio optimization. So I was trying to find some relation of how to maybe earn money on investments area with support of portfolio problems, but the most important thing was that I used the conditional value at risk and value at risk measures of risk for this portfolio, and these measures of risk are also applicable later in my continuation of the research. Then I switched to vehicle routing problems with some logistics processes. I had some research collaboration with grocery companies in Spain, like the Mercadona, Eroski, how to optimize the network, the deliveries, and so on. Recently, I was involved in lockers, so that's why there is a picture with automated parcel lockers. You all know the lockers, like the InPost. Actually, the InPost is probably at the moment one of the leading company in Europe. So I was involved in some projects with how to optimally locate the lockers inside the city to catch demand, okay? And in the meantime, from time to time, I was trying to do something for our healthcare system. So I have some publications related with multi-criteria optimization, with the assignment of resources in the hospital, also about the robots for the elderly people. So different area, but this is, more or less to explain the movement of and development of my research career, why I decided to move to space industry. Okay, generally speaking, this is the relation between these pictures and the area of interest. So all the time I was trying, I like this multi-criteria, so I'm trying to use the multi-criteria problems for different area, okay? Always with some measure of risk, which is value at risk, conditional value at risk, which is very nice measure of risk because we don't need to know what is the statistical distribution of the data, okay? So we just take the data from scratch, and if we need to calculate some risk level or service level, because you can do different things, you can measure the extreme level of risk, or conditional, it means that, for instance, we have some scenarios of disruption, scenarios of different negative impacts to some situation we are considering, for instance, launching the space mission, and we are just considering the issue of 5% of the worst cases, 1% of the worst cases. And it might be risk, it might be the service level, it might be the time, it might be the quality. We can measure different things with this measure of risk. And as I said, we don't need to know what is the statistical distribution. Okay, so this is more or less the repetition of the things I've done. So more or less that you will be familiar with my research field. And what kind of methods I usually use. So with the multi-criteria, I like very much the fair optimization. So the situation that we have two criteria, for instance, three criteria, which are going to the opposite side. For instance, we would like to do something very quickly, very smoothly, and we have the limited budget, and there are some restrictions about that. And fair optimization will try to find the trade-off solution, yes, or set of solutions, non-dominated solutions of how much money we have to put to the process we would like to achieve, like launching the mission. Very easy and nice multi-criteria method is also weighted approach, lexicographic approach, reference point. There are different, let's say, state of art of the modeling of the multi-criteria. I'm usually formulating the model, which are the mathematical programming with exact approach when it's possible. When it's not possible, there's some approximation. For instance, for the logistic processes with the VRP was not possible to use the exact methods. And I'm trying to formulate the model as a mixed integer programming with some constraints, which are, I'm trying to keep the model linear, so no multiplication of decision variables. So the perfect software for that is the solvers like Cplex, Groby with AMPL programming language. Recently, I'm also using the AnyLogic for some simulation processes. Okay, and about the space technology, what I was think that would be a starting point for explaining why the multi-criteria would be useful. So we can consider the supply chain for space mission, and if this is a supply chain, where there are a set of suppliers. We have many criteria in this kind of problem because there are some costs, there are some time for delivery, the quality, the resiliency, so some mitigation of disruptions. And all these models, if we are including risk, I recommend to use this value at risk, additional value at risk, and any modification of that. So not only risk, but also, as I said, the quality, service level, time, something which is measurable, yes, and we can try to build a set of scenarios for that. And at the end, we have some characteristics, how the process will look like if we're going to model it. That's why I'm going to also try to convince you that maybe connection between multi-criteria optimization with digital twin and metaverse would be perfect, because we can do something, let's say, not in scratch, but before we are doing this physically, yes, some processes. Also, I had some experience about the cybersecurity portfolio problems. So this area of the space mission, I think, might be also considered with optimization modeling. And well, and the last one, yes, is like the connection on everything. So the digital twin and the metaverse with multi-criteria optimization of planned space mission, considering conditions, modeling, and mitigation of different type of risks, different factors which might, you know, be important. Okay. This is just an example. This slide example, because I have one paper about connection between space mission, multi-criteria optimization, and this issue related with different measures of risk. So this is just an example of different criteria, and I choose some of them by purpose because the first one I think is not very commonly known, and to how to measure the minimizing the stress level related with the space mission preparation. And I have to tell you that I was come across with this idea because I found a paper about measuring the stress level of the physicians in the hospital, okay, with the flow of patients and how to change. And this might be also transformed to numbers, yeah? And if we're going to consider it as one of the criteria, not very important, but one of the criteria, we can also put it to the knapsack of different parameters. So in red are the minimization, in blue are the maximizations, and we can consider a different combination of that. Just as an example, it's not limited to this criteria. This is just an option to consider. Very simple slide to convince you that it makes it. I think it's better to consider a multi-criteria optimization than single objective problem in the space mission. Imagine that this is some kind of stages of planning the space mission. Well, I could say that I'm neophyte in the space mission industry, so I'm not going to say that I'm an expert in that. It was just my, let's say, way of building a model, first of all, in mind how it works in stages. And if we take into account, for instance, 3 different criteria, and we solve each problem as a single model, so without connection with that, I think this is very obvious that it's much better to connect and find some kind of equilibrium, some kind of trade-off between them. So what is the impact between? And well, in stage 5, I think this is very well explained, because the decision maker, if this is the multi-criteria, is capable to choose the best decision alternative from interconnected solution of a non-dominated set of Pareto solutions. So what we're going to have? We have some kind of space, and this space will show us costs connected with time, connected with the supplier delivery of parts, connected with some deadlines and everything else. So it's everything in one basket. And at the end, we know what will happen if something is going to be collapsed. Okay, so if there is some kind of risk, what will happen? What would be the impact of that risk? So this is that's why I thought that this slide would be interesting to consider. Okay, and now I'm going to switch to digital twins, because we have to. I'm trying to convince you in my talk that is maybe better, and probably is also quite obvious for you as an expert in the space mission planning, that is better to do something in a virtual way, and then if everything is well modeled and we know what will happen with the connection, to move to the physical entity. So this is an example of different digital twins of from airline industry to satellites. Okay, so how it works and what are the challenges? Because I was thinking to build a model, multi-criteria optimization model, which combines information with use of digital twins. There are some challenges because first of all, we need to have some data transmission delays, some model accuracy, because formulating the mathematical model is at the beginning is easy, but probably you know that this is like all the time improvement. Yes, you solve the problem, you see that something is not working. At the beginning, it looks like you consider this constraint, this objective, everything looks perfect. Then you start connecting this with some practitioners, and it seems to be that is not working. The results are not reasonable and not applicable. So the challenges, this is one of the challenges. Fault detection, diagnosis algorithm, so different aspects which take a lot of time to formulate the model which is going to be useful. The issue with what we can consider from the digital twin is that probably we are able to find all the aspects which save money before we going to build the physical formulation of the model based on the experiments with the digital twin. I also searching for what's going on in the research field with that, and I have found some examples of application of the digital twin in a space environment. So I just find some information about advantages about that. So we are able with the digital twin to enhance the safety and the reliability of space mission by creating some precise virtual models. We are providing a powerful tool that enhances the safety of, well, different aspects. Are we going to build a space mission or a spacecraft, or a different tool which is going to be launched to the space or some space station? So this is something which is very reasonable to apply and not easy from the mathematical modeling, because it takes time from the beginning to build a good optimization model. But at the end, is very profitable because we are able to save money and save some time because of the errors which we maybe not notify before if we are not going to use it in a digital twin way or in a metaverse with some virtual reality. So if we have the digital twin, we need a metaverse, and for the metaverse, again, well, this is the situation. Like this is an example. I also trying to find something about this, and this is Accenture and NASA Space Agency, where they're collaborating with the metaverse for the space mission. And I think the most interesting part is this part of the presentation when we have identified the process. We are trying to apply some optimization models, and then in the metaverse we can simulate everything. Yes, even like if this is the kind of artificial village on the moon. Yes, we can, in the metaverse, we can do everything, the modeling, this, optimizing, and trying to consider different scenarios. I think this is reasonable to apply this kind of issue, because it's not very, very difficult, but it's safe. It will save a lot of time and money if we're going to model it before we're going to use it in a practical way. And again, I was trying to find some challenges and advantages briefly, okay, because probably the list might be very long, but I think it makes no sense to consider a lot of issues. So of course, I was thinking how to do it, okay, with my experience of the multi-criteria models, how to do it effectively. So again, we need some kind of data integration and accuracy, some kind of hardware, software experts to model it, yes. And advantages, well, advantages are very, very obvious. So this is a very cost-effective prototyping way of process, because we don't need to build a prototype. We are building a prototype, but in a metaverse, yes. So everything is much easier to apply. If we're going to consider this risk analysis with multi-criteria, we can consider different factors, combine them together, and probably that will save us, again, money and time and efficiency of the problem. One thing, you don't see this, but I put the information which connects everything. So I said that the multi-criteria optimization approach combines all the aspects of space mission in a complex model. So we have the digital twin, we have the metaverse, we have the tool of optimizing the processes. We can consider it in a different area. So like here in this, we have some strategies to consider, some different products. We are considering the suppliers, some international collaboration, and everything in one basket, yes, taking into account all the aspects to run the mission, or run the mission before running the mission, yes, because we are doing this virtually. Okay, and I was also thinking about some examples, because I have to come across with what I would like to do, okay? So I remember a short discussion with Professor Ruhl about the lunar dust adhesion. And I was thinking that if we have the digital twin mitigation model in metaverse with multi-criteria, well, maybe we can do something. Well, this is, I'm not an expert, okay? So if this is very innovative, I hope that we will accept it. Well, what to do with this dust? Maybe the car windshield wipers. So something like a solution like the automatic cleaning brush with the dust sensor, or some kind of resilient material. Probably the resilient material will be much easier to implement to remove this dust. But if we have the data, because again the problem is the data, we have the data from the moon. What is how this dust is sticking? Yes, what is the adhesion of the dust to a different tools? Maybe we're able to, in the metaverse, to model it and try to implement some solution before launching to the moon, because it's too costly. This is one example. Moon mining with the extraction of helium-3. Again, we can try to do a different tools, different approaches. If it's possible to model the tool, well, we can do it in metaverse and try to use it. The mission planning is quite obvious. Disaster scenario planning, as I said, with this different set of criteria and risk measures, I think this is must. Yes, we should do it like this before we are launching the mine. I was also thinking about some cooperative game, because recently I'm trying to build a multi-criteria model with fair optimization with connection with the cooperative game. When we have the supply chain, and this is a space mission of international supply chain. So we might have conditional service level, risk, conditional value at risk, and again, model digital twin of the process of this kind of supply chain. In a metaverse, we can model it. Yeah. Okay, and well, these are the examples I was thinking about. And one thing I'm now doing with my colleague Alain Del Val from Tecnalia in Spain, from the Basque Country, we're applying for the grant about. Sorry, I have to read this because we don't see multi-criteria optimization for supporting manufacturing processes in designing of materials in space environment. So this is very engineering grant, but again, I'm trying to implement the multi-criteria optimization with connection with the digital twin and metaverse. So not only the very engineering way of designing some new materials, but also trying to model it mathematical way. Okay, and as I promised to Professor Ruhl not to have so many slides, I'm trying to go to the main conclusions. They're very general because I think the conclusions I was trying to give you the most important things during the presentation. So what are the limitations and what are the applications? So the main limitation of the multi-criteria optimization is that, well, the data, not only the availability of the data, but also the way of connecting the data with the modeling software or using some C++ or something. Yes, but if we have C++, well, I need the branch and bound, branch and cut algorithm to build from scratch, and sometimes it's not as efficient as using ready available solvers. The issue of the trade-off conflict of objectives, because this is a very important philosophical way, which objectives make sense to consider and which is silly to consider and takes time and are not going to give us any new information. And the application, so we have the options to build a comprehensive understanding of all important factors with different risk scenario, with different what-if analysis. We can model it with virtual surrounding and then apply in a real mission plan. And the references, please excuse me that I have just 1, 2, 3, 4, 5, 6, 7 references, but I thought that 150 would be not a good option. So I just choose these papers because I was trying to find recent or most interesting information about application of the metaverse, application of the digital twin, and my background of the multi-criteria optimization in the space area. So some of them are recent, some of them are not recent. Also, this issue about the adhesion of the lunar dust was available. So more or less, this is my part. And now I will go to the first slide, and I'm looking forward for the question from the audience. I'm trying to do my best to answer all the doubts and questions. Thank you.
We have a lot of questions. Okay, have you any questions? Thomas?
Thank you for your presentations. I never thought about using those technologies yet. I would be very curious if you could give us some of the examples, like from the last list of the references. What would be the successful examples of implementations in the context that the biggest drawback that I see for that is that a lot of missions that we're doing are exploratory, and you say that this model heavily depends on the data that we don't have yet, right? Mm-hmm. So does it mean it's, what kind of projects then? Is it more useful than exploratory ones? And so the second question to follow up is that if we're trying to save on the pitfalls caused by risk mitigation, like the risky points. We're trying to avoid costs associated with risks. But on the other hand, we have to hire someone to model all of it because we're not unable to work with the metaverse. We need a special person for that. And how does that balance?
Okay. So I noticed there are like two parts of your question. So first one, yeah, okay. So first one is about application. So this example of the metaverse with the space is not my invention. It is an Accenture collaboration with the NASA. So we are doing this now. So it's not science. It's not a science fiction. We are applying this metaverse for the space mission. Actually, this is the last reference. Yeah, okay, because this is based from this presentation. So this is the first part of the answer, or your first question. And second question is about the cost. Well, probably if you make a trade-off between cost, how much money you will pay for hire someone expert from the metaverse, comparing the amount of money you can lose because of some faults or things you are not considering with the mission. Maybe you will save that because you use the metaverse. Probably the balance is, it's just like 1% to 90%. Or 1% to 99%. But I cannot give you the exact amount. I don't know what is the salary for someone who is an expert in the metaverse. Probably sometimes is a very, let's say, motivated and gifted student who is starting something, and we are guiding this person. But it depends. Probably there is a need. There are real money. There is a time frame. So it's not the time that you are going to build everything in the metaverse with the digital twin and waiting 5 years, and you're going to launch the mission in 1 year. So it makes no sense. Yes, it's not like to build a PhD thesis based on that, because so it depends really on the situation. But I'm pretty sure if we're going to consider the amount of money for hiring someone who is an expert in that, with amount of money you lose in the mission because you are not considering something, well, you're doing this step by step, but in real life, in physical situation, and we are not masked, so we don't have as much money as he, so probably is not comparable. It's 1% to 99%. 1% of investment to 99% of losing. 1 to 100 or something like this. I think that would be the answer. Yeah.
Okay.
This is okay. So thank you for the question.
I have several ones.
Okay.
Okay, that it's the first remark is that the digital twins for space science, I can say, that is on the introductory step. For instance, in the mechanical engineering, we use digital twins for even each task we can do that. But in the space, they just started. Last year, I participated in the conference for simulation for space application in ESA in Norway. But I asked about the digital twins. They said no. But now I know that they started the project, big project, digital twins for Earth.
Mm-hmm.
They want to simulate Earth from the point of view of the space. Yeah. This is a new project. My colleague is a supervisor of this big project in Europe, David Wack. And this is very interesting project because there is so many criteria to build such a model, a lot of uncertainties. And also regarding this what you said, no data. There is two kind of models which we can apply for that. This is one model is data-driven, based on the data, and the second is physics-driven. Means that we can build a very uncertain model using the raw data, but after that we can update, improve the model based on the physics. Yeah? This is a common approach now in the mechanical engineering, but in space they just started to build such a digital twins and use these digital twins for the exploration. This is a very interesting subject and in very interesting directions of the research, because in fact, if we are doing some research, in the conclusion we are trying to find a model for the data, the model for the phenomena, and so on, to generalize the knowledge, yeah, based on the model, not on the data directly, but on the model. This is a common way for the research, in my opinion. But of course, it's under discussion. Okay, the second directions of the research which you show us here is cybersecurity for space. This is a hot topic. And during the discussion of the last scientific board of the CTK, one colleague from Germany said, okay, we should work in the cybersecurity for space. This is very important. We a little bit touched the problem, but this is not what we did the research on that impact. Yeah? And this is also very promising directions of the research, and we will possibility to cooperate with many international institutions on that, because this is a very hot topic for space just now. Yeah, and also
May I comment this first too?
Yeah.
Yes, before you will continue, because I imagine that the professor have
a
lot of comments. So
yeah.
I will start with this because I was thinking, like an early absorber, what I will do with the digital twin and the issue of the space. If this is you can do it for the tool. So you can use the digital twin for small size tool and then expand the spacecraft or the space mission itself. So it's like from the detail to the whole. I think that would be the easiest path to, let's say, apply the digital twin in that area. This is my comment about the first one. And about
but we need at first, which we start to build the digital twin for some phenomena, we need to define the boundaries.
Yes, of course.
Because for universe to build a digital model,
no, it's like in any optimization model. You need to have some constraints, and then you can build the model and consider different criteria. Because without that, it makes no sense. It's like the philosophical issue. And about the cybersecurity, I have one experience about the cybersecurity model. Again, with this conditional value at risk constraints. That was the cybersecurity model. Cybersecurity portfolio, which is dedicated to be resilient for any cyber attack. And the cyber attack was the kind of set of scenarios of different attacks. So again, there are some boundaries because there is a limited, of course, scenario. You can expand it. And this measure of risk was very useful, was very promising to apply, to build a model which is resilient. So at the end, there was information how much should be invested to be robust. So that model was robust for this most, let's say, devastating scenario of the, how to say, hacker, yes, or someone. So more or less, the methodology is similar because you need to protect the environment, some software, like I imagine, like in a space industry. So if this is a bank or this is a space industry, the cybersecurity is to protect the software, protect the, let's say, your neighborhood. That doesn't matter if this is there. And with this measure of risk was very nice. This result was very interesting.
Okay.
Yeah.
Okay. The last remark which I have just now, of course, this is about multi-criteria optimization for space mission planning. This is a big subject now, the human mission to Mars. Because Elon Musk said that he will organize such a mission 28, and there is a discussion, and I was a reviewer on the paper on that. The paper was, is it possible that Elon Musk will fly to Mars 28? This is a big optimization problem. Because he proposed, Elon Musk proposed, that will be 12 launch with a carrier to travel with propellants to Mars to tank the spacecraft to return to Earth. Yeah, that is a big logistic problem to solve this. Of course, in the paper was the conclusion that it is impossible because of the cost. Yeah? The cost was not a billion but trillion of dollars. You know? The cost of such a mission, human mission to Mars. The crew was 12 people because, and they will stay on Mars for 500 days because the trajectory of the Mars and Earth mutual trajectory suggests that every 500 days they are close, a little bit closer than in origin, yeah, because they are not synchronous, yeah. And this is a big problem. There is a nonsense to organize shorter mission because the distance between the Mars and Earth, if they will, for instance, for a mission for 38 days staying at the Mars, means that if they will come back, they should go through the Venus, and this is very risky, very close to Venus. That it's only one possibility that the people will stay on Mars for 500 days, and this is also a challenge because we need to transport them the food and so on. There is several options discussed, but they didn't do any optimization. Yeah, and I see a big, in my opinion, big opportunity and also possibility to make the optimization of such a mission. There is a lot of papers, a lot of materials about the missions, because the first mission was planned by NASA 2009, sorry. The second was 2018, but now it's a mission of Elon Musk. And there is a lot of gaps for the optimization process.
Okay,
there is a lot of multi-criteria because cost, safety, risks, and so on, and some technical issues. And in my opinion, there is a lot of space to make research on that.
Yeah, it's interesting. So they are on the stage of planning and considering different, let's say, risky areas, but they are not optimizing anything. And the problem is that they can launch the mission or not. And if we're going to consider these three methods, maybe we are able to model everything before launching the mission. That would be interesting to see how it will look like. Yeah. Putting additional risky scenario, what will happen, and more or less probably is much easier. That would be much easier to
available on that. Not only from the NASA reports, but also from the papers. And I see the space for the optimization, multi-criteria optimization. Yeah.
Well, it sounds great.
Okay. A few more questions, comments, discussion? Yeah.
Thank you very much, Professor. Maybe not a question, but a comment. Super interesting presentation.
Thank you.
And as a comment, if you only you would see such an opportunity, it would be like a super interesting, super exciting for me just to try to make something in common. And what I may provide, I mean, my background is like a computer science. And also, what is more, my PhD thesis was dedicated for multi-criteria optimization. But with applying or using the not the exact, but like approximated method, like the soft algorithms, like what was there, like evolutionary based or agent based computations, and so on and so forth. So that would be what I may add. Additionally, like my habilitation was based or was focused on computer simulations and modeling, and that is also addressing the first question: what about how to deal with lack of data and so on, right? Because, for instance, we try to build a model for Saudi Arabia, how to optimize the exploitation, some natural resources, right? Of course, there will be some differences. There will be some maybe like some alignment needed, but by facing the lack of data, we might try to apply such existing models. And as Professor said, try to improve it, try to fine tuning it, and so on and so forth. Like as I said, I would be like super interested in trying to do something. In try to maybe to compare like exact algorithms and this approximated approaches or something like that. Because I'm also like new here in the space center, the GH, so I'm also of course interested in looking for it, starting doing some research, and that would be great to the topic for me actually. So thank you very much.
Thank you very much for this comment. I'm looking forward for a collaboration, but when you say all this information, it came across me some things I'm expecting is going to be. Even this is a lack of data. Probably these problems are not small. So probably the exact methods will not be an option to solve this problem. So I can see what are the obstacles with this with this multi-criteria optimization for the any space processes. Well, even we have lack of data and we can model the data with some experimental data, the flow of data probably will be enormous. So probably to find a solution with the exact methods is very small laboratory size of the problem. For the real mission, probably we will need some approximation algorithms, as you mentioned. This is the one obstacle. The second obstacle is that, well, if this is multi-criteria, we don't have solution which is one solution, which is good because we consider a trade-off between. But it means that we have a amount of solutions, yes, amount of connected solutions. So there is also a need of experience how to make the interpretation of the solution, which is the one as a decision maker is going to choose. And there is not only the issue of data, but there's also issue of expertise, someone who is experience in that, because we will have a lot of results, but interpretation of the results is a clue, I think.
Yeah, that we use a physical informed model building. That we have interpretation. If we use only the data, we have no interpretation because we have the black box with the data, and we build the model for the black box. But if we have also the physics, overlap the physics of that, we have interpretation.
And that is also what I wanted to ask, like, are you focusing only like on the multi-criteria optimization, or are you doing in your research like what's the further like decision making? Because these are totally two different, aspects, right? One thing is like to find the set of non-dominated Pareto set or Pareto frontier of non-dominated solution, and then it's totally different, thing just to make a decision which the option of out of the non-dominated solution is that I would like to to apply, to follow, and so on and so forth. And there are also a lot of methods to support to do such a multi-criteria decision.
But
right?
also under the uncertainties.
Yeah, sure.
There is a lot of methods that we can deal with uncertainties.
Yeah, precisely. And that was my question.
Thank you for this question. Well, the pure multi-criteria optimization is like you have the glass, and you have the hot water, and you have the tea. And would you like to drink a tea? You have to connect everything. So I think this is for decision support. More important is to build the multi-criteria model with digital twin, with the metaverse, or only multi-criteria, but not the model for the model, but to show the possible, let's say, decision options, yes? Decision analysis for the decisions. So this is purely decision support system. So the purpose of applying this is to have a supporting knowledge how to plan the mission, what steps are essential, which are not important, which are important, more or less. So the answer is yes. The answer is more important is decision support system. The methods, as Professor said, there are many methods. Some methods maybe are fine for this mission and for the other problem are not okay because we have a different data. The mathematics is mathematics, you have to choose, but the purpose is to support the process, yes, for sure.
In your research, are you, trying to finish or to complete or to follow or to end up with the decision, or are you focusing only like on the finding or the decision options, like on this set of non-dominated solutions, right? That was only my question, just out of curiosity.
Well, I will answer in 2 steps. The 1 step is, of course, at the beginning was fun to play with these methods, yes? And one of the reasons I was trying to evaluate some innovation project, I also in Berkeley to notice, and now I think the fun is when this is applicable, yes? Yeah, sure. When this is practical, applicable in the practice. So it's like in a business. If this is something you can sell, it's worth. And this is purely theoretical, okay, but maybe not in a space mission process. It's not theoretical because you launch something and you send people. So you would like that the people are going to return to Earth, yes?
Yeah, would be great.
Yeah, you can make this experiments, but not with the...
Yeah, it would be great to not make a one-way ticket. One more question, if you don't mind this. Again, just to understand, you mentioned or you use the term like a funnel optimization. Is it the same like a Pareto optimization or not really?
There are some. The difference is that in the FAIR, in Pareto, you are moving between different, let's say, priorities, yes. And in the FAIR optimization is like.
No. Pareto optimization is like finding the non-dominated solution.
Yes, the non-dominated solution. In non-dominated, yes, sorry, the non-dominated solution. In Pareto is non-dominated solution, but in the FAIR optimization is like is more related with the cooperative game, yes. So if you have several criteria, you are trying to find a solution which is a kind of trade-off. Yes, trade-off. But yeah, but this trade-off is a way like you, for instance, in a Pareto you have the trade-off and you see what is the difference between. And in FAIR you can set up some level of priority. For instance, that the satisfaction of cost versus risk would be, for instance, on a similar level. Yeah, that is my way to explain the difference. Yeah.
Thank you very much.
Magda, have we any questions on chat? No. Thank you very much for
Thank
very
you.
Interesting presentation, and I hope we can in the future to cooperate and solve some important case exploration problems with you. Thank you very much.
Thank you very much for the invitation once again and for the questions. Thank you.